don't know the population mean. We're looking for a mean. The mean length of work. The mean length of time to get to work. So we do not know the population mean. So if we find your sample mean, this is your point estimate. Write this down for your population mean. This is the whole reason we do this. So that we can infer something about your population based on your sample. So we put this into L1. Anybody come up with a mean for me? 9.5. Closer? Okay. So our point estimate is our mean, 9.5. Okay. Do you have a sample standard deviation while you're there? 7.10. Okay, good. All right. Now, I want you to work out your margin of error and your confidence interval. I don't have this one. You need the other more? Oh. Okay. That's right. Okay, bye. Okay, find me your margin of error formula. And in this case, we're going to use you can use your sample standard deviation because, first of all, how do we know we're using a Z?
Because it's more than 30.
It's more than 30. It's greater than or equal to 30.
Technically, wouldn't it already be more than 30 because on this degrees of freedom chart, it gives you the original one anyway?
Yeah, well, your degrees of freedom chart runs into your Z-score, like when you hit the infinity chart.
When you already go above 38.
It automatically turns into Z.
Okay. You wouldn't really, if you didn't know.
Yeah, it would automatically hit it. Yeah. Okay, how do I find ZC? That's a problem. How do I find ZC?
On the chart.
Well, this is a Z-score, not a T. Inverse norm, because 90% of your data falls here. What's left? 10. What's half of 10? 5%, so you're going to do inverse norm 0.05. You can actually do inverse norm, do it all in your inverse norm. 1 minus 0.90, parentheses, divide by 2. Let inverse norm work the whole thing out for you. Just make sure you put your decimal in. So what is your ZC?
1.645.
Good. 1.645. We're going to use our standard deviation from our sample because we are greater than or equal to n, and divide this by 32. So what do we get for our margin of error? Do the one decimal place. Point, you got 0.01?
Oh wait, I think it is
2.1?
Yeah.
2.1.
How do you know when to use 3 decimal places?
Your rule of thumb is this. If your data, always go 1 decimal place more than your data. So our data had no decimal places. So when we do the mean,
for,
go 1.
the 90%.
Normally you do 2 decimals. But the 1.645 and the 2.575 just happen to go 3. If you go 2, that's fine. And your calculator rounds totally different, so they don't round at all, so whichever way you use. Now, you build your confidence interval like this, whether it's a Z or a T, and I need to see the whole thing worked out. 9.5 plus or minus 2.1. I need you to subtract this, and I need you to add this. So here's your interval. So what does that exactly mean? Why did we do this? What is that interval? How do we interpret that interval? Yeah.
You have 90% confidence that it will fall between 7.4 and 11.6.
What will fall?
The population.
Good. Absolutely great. You are 90% confident that your population mean will fall between 7.4 and 11.6. It's not your sample mean because you're 100% confident your sample mean is there because you found your sample mean. but you are 90% confident that you inferred this about your population. That's really important that you understand this. So we followed our flow chart. We knew this was a ZC. We found the ZC one. We plugged it in. Can you do this in your calc? Stat, test, Z, interval. If you happen to put this in your L1, you could actually use the data part of that test, because then it pulls all your information out of your L1 table. Or you can just go in and put it in, whichever way. Do you have a question? Well, we don't know the population mean. We only can find the sample mean. We only found your sample mean. We don't know the population. This isn't all the length of times of everybody. This is just a sampling of 32 commute times. No, T-square is only when we follow the chart. If it's less than 30, if we don't know the population standard deviation, then we not.
You use the sample standard deviation.
Yeah, well, because these are your samples. S for sample. Okay, any questions on this? All right. The next one says, they want you to construct the confidence interval for a population mean for this. They gave you all your pieces. So again, we're doing this. So the first thing we look at is n. Think of your flow chart. Is n greater than or equal to 30?
Yes.
Yes, so what do we use? ZC. We use this guy. We're going to need your ZC for 95%. So we do inverse norm.
You're giving us a flow chart, you said on the test.
I'm giving you the flow chart. So this comes out to be what? 1.96. So we're going to plug it into your margin of error. You have all your pieces of information. Because normally your formula says population, but remember, if it's greater than 30, we can use your sample standard deviation as your population. Divide by the square root of 100. So build your margin of error, and I'm absolutely fine with you doing this on the calculator. So your margin of error turned out to be what? 0.05. And you want to build your mean now. Now here's the difference. If you rounded this to 0.1, because you kept it the same here, then you're going to be 10.3 plus or minus 0.1. You're going to be 10.2 to 10.4. If you left it, because that's probably a little bit more exact, 0.05 rather than 0.1, you could actually leave this. It's up to you. If you want to round to the 1. If they're asking you to compare anything, definitely break it down to the smaller unit. Okay. If you do this on your calculator, remember, you take your high end and you subtract your mean. This gives you your margin of error. Okay, so you can use your steps. Make sure you show me what step you use. Because here's the problem. If you do a Z and you should have done a T, and I don't see that you did that, everything you wrote down is wrong. There's no way I can give you credit. If you wrote down a Z interval and you were supposed to do a T, at least I say, okay, you got the wrong T, but you get partial credit for doing the rest of everything right. So make sure I see your step. Okay. Now, your results from example 2. Example 2 said, take this and determine the minimum survey size that's necessary to be 95% confident that the sample mean length of work commute is within 2 miles of the population one. There's your margin of error, within 2. Anybody remember the formula? I have to give you this one tomorrow. No, for sample size. For your sample, actually, if you look over to the page next to this, sample size. Yeah, the whole thing is squared. Make sure you square the whole thing. Your ZC we knew it was 1.96. Your standard deviation, I forgot, was 7.1, thank you. Over, there's your new margin of error. And then you're going to square this. And what do we do when we find our answer? Round up. Okay, so you put this in, we find your n to be 48.4, and we round up to 49. Always round up. You can't take a partial person's time here, and we did full minutes on this. Actually, we just did minutes. So we don't have any partials. So if you cut it down to 48, you would have never hit 48.4. So you always have to round up on your sample size. This does come from your margin of error formula, same formula, just transpose. Transform. Good? Questions?
Wait, to do that, do you have to put everything in parentheses like that?
Yes.
So that
Yes,
you
you
can
have to square the whole thing. Unless you do it, you could do it the other way. You could do it in your calculator.
like separate
This
and
times
then
this, divide by this, enter, square, enter. Okay? Alright. Number 9. Number 9, we're into 6.2. So they want us to find a TC, a critical value. Find your TC. How do I find my TC when my confidence level is 80% and my N is 8? What do you think, Gunnar? Are you Gunnar? Yes? What do you think? How do we find your TC?
You have to go to your chart.
Very good. We're going to go to our chart, table 5. Very good. Table 5, T distribution.
You gotta go with 7.
Oh, good. Degrees of freedom, n minus 1. So come down to 7, and what do we do across the top? Oh, 80. Find your TC.
Are we gonna get this thing on?
You get your chart. I don't expect you to memorize it. You could use inverse T in your calc too, but you got to do the whole thing like the inverse norm, which takes longer, I think.
And that's all they're asking for, right?
That's all they're asking for. They just want your TC value. So what do you get? Thank you. That's all we needed to find. Can everybody access that chart? 1.415. Okay. Now we're going to build.
How do we show work? Like,
You don't. There is no work. You can show me your degrees of freedom. That's about it. There's no work. If you used inverse T, show me what you put in. You'd have to do the 1 minus 80 divided by 2 thing. Number 15, we're going to find your margin of error. This has your same exact formula, except it uses TC. And of course, because our sample size are smaller, we usually don't know the population if we're going to do a T, we're using our sample standard deviation. Be aware, I'm going to ask you to do this. I'm going to ask you to find margin of error. If you do it with your interval, you can always do it in your calculator, subtract it, and go backwards and give you margin of error. But you got to show it to me. So, I got to find my TC for a 98% confidence interval. What's my degrees of freedom? 11. So I'm going to look up 11 and 0.98 and find my TC. So find me that first. 2.718. Thank you. So now we're going to plug this in. 2.718 times your sample standard deviation divided by your square root of n. See, your n is less than 30. Plug this in and get your margin of error. This is your plus or minus to build your confidence interval. 0.71. Everybody see the difference between a Z and a T? No, for this question, they just wanted margin of error. On this exercise, it just said find the margin of error. The next one, we'll be doing an interval. Remember, I'll give you the flow chart, so you have to go through the flow chart, determine which one you're going to use. Which has a wider interval, a T or a Z, for the same data? T. Good, because it takes into account any problems with the samples. So it gives you a little bit more wiggle room. Remember how much easier it is to find an interval than it is to find the point. And I was kind of hoping when you did your margin of error articles that you would kind of see that. That it is far more difficult to find a point. Like, that's why they do your margin of error and they create intervals. And a lot of the articles you did kind of said that in there. So we found our margin of error, which was 0.71. No.
Yeah.
0.71. Okay, thank you. We found that, and now we're going to build your confidence interval. You build your confidence interval the same way. Same exact way. Don't leave it like this. Take your mean, plus or minus 0.7. Now, you need to do the whole thing out. Subtract it and add it. I don't care if you write it this way or you write it this way. I think this helps you make more sense out of it when you write it out as an inequality rather than an interval notation. You want to be 98% confident that your population mean will fall between 6.1 and 7.5. You already know your sample. This is not to find your sample. This is to infer something about your population mean based on your sample. It's not 98% of your data sits here. 98% confident that your population mean will be there. So now instead of picking one population mean to be 6.8, I get a bigger range of numbers to pick from. Right? I have a better chance of hitting my population mean. Okay? Okay. And the last one, you guys try this. Do this first. Minus 15. What's the average repair cost? For our sample, 80. What's your sample standard deviation? 14. We want to be 90% confident. So are we going to use a Z or a T? T because
they don't give you the population.
they don't give you the population and we're less than 30. So we're using a T-score. So the first thing I need to find is my TC. What's my degrees of freedom? 14. So look in your table at 14 and 90%. 1.761, thank you. So, margin of error, 1.761 times your standard deviation over your square root of n. Not your degrees of freedom, your n. So, margin of error, 6.4, thank you. And we're going to build your confidence interval. So 80 plus or minus, you can go 6.4, you can go 6. I would probably go to 6.4. Theirs was a flat 80, but you can go 6.4 if you like. It doesn't really matter. So 73.6 to 86.4. There's your interval. Now, if you do this on your calculator, that's fine too. Right? That's fine too. Bring it back. Take the high end and subtract your mean. There's your margin of error.
Number 7, how do you know when to use that formula?
Number 7, wait, let me just step back a second. Because it says determine the minimum survey size. Whenever they say size, sample size, n equals. If they want intervals, then we do this. If they want size of something, that's your n, your sample size. I said survey instead of sample, but it's the same thing.